Okay, here's the question. Given this rather unsightly polynomial here, what is the final coefficient of the x term? Well, first of all, let's take a look at this thing. It is a big, ugly polynomial. Anything to the 2012th power is going to be nasty and probably impractical to calculate all the way through by hand or even with a calculator. So, the good news to that is there's probably a simple way to solve this problem. And I think I figured that out, so let's see how this looks. So what I'm going to do is I'm going to cut this polynomial sort of in half here. I'm going to cluster these two terms, and I'm going to call this right here A, and I'm going to call this right here B, so that A is equal to 7x to the fourth plus 2x cubed, and B is equal to negative x plus 3. So that the polynomial reduces down to a plus b to the 2012 power, which is still ugly, but now that we have it in this form, a plus b to the 2012 power, we can apply Pascal's triangle. And if you recall Pascal's triangle, it looks a little something like this. It's a triangle with ones going down the side here, and the term, and there's a 2 right here, and the term, each term in the middle is going to be the sum of the two terms right above it. So 1 plus 2 is 3, 2 plus 1 is 3. If we went down another level here, and each of these levels represents the coefficients of this polynomial raised to the nth power. So if we look at the second level here, that's 1, 2, 1. That would be the equivalent, those would be the coefficients to the polynomial if it were raised to the second power. So a plus b squared would be equal to a squared plus 2ab plus b squared. If we raise it to the third power, we'd get a cubed plus 3a squared b plus 3ab squared plus b cubed, and so on and so forth. And the fourth level would be 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then we have 1s going down the side here. Now, we could take this all the way down. So the nth level of this triangle represents the coefficients for the nth order polynomial, which means that if we went down to the 2012th level, we would see that, well, these numbers here count up 2, 3, 4, 5, and down on the 2012th level, we know that this second coefficient would be 2012. And we know the same thing over here, 2, 3, 4, down here. The second to last coefficient is going to be 2012. And the stuff in here, we don't really know, and we're not going to really care, and you'll see why. So if we use Pascal's triangle here and apply these coefficients, we'll see that this polynomial here, a plus b to the 2012th power, is going to equal something like a to the 2012 plus 2012 a to the 2011 times b to the first plus a bunch of stuff in the middle, and then plus 2012 times a times b to the 2011 plus b to the 2012. Now remember what a is. A is 7x to the fourth plus 2x to the third, which means that anything multiplied by really any power of a is going to give you a bunch of terms with x's that have a higher power than 1. And remember, we're interested simply in the coefficient of x to the first. And the only place we're going to find an x to the first in all of this crazy multiplication and all of these terms is the last one. Everything else is going to be at least, everything out here is you're going to get at least x to the third power right here. So the only term we're really interested in is this right here, this last term, b to the 2012. And remember, b to the 2012 is equal to negative x plus 3 to the 2012, which is a lot simpler than what we had before, but like I said, anything to the 2012 power is a big polynomial. Well, okay, well, again, we can apply Pascal's triangle to this polynomial. But before I do that, don't make the mistake of simply distributing the power to each of these coefficients. Okay? And you can't simply do that. The coefficient of x when we're done solving here is not simply going to be -1 to the 2012 power. And as a counterexample to all of that, let's say, suppose we were just simply interested in b squared. Well, b squared would be equal to -x plus 3 to the second power. Well, you can't just say -1 to the second power. You have to do the whole thing. This becomes x squared minus 6x plus 9. So you can see right here that the coefficient in front of x is -6, which is very clearly not simply 1. So that's our little counterexample. But what we can do is apply Pascal's triangle right here to the polynomial that we have now and see what happens. So this becomes, if we did this out, this becomes -x to the 2012th power plus 2012 times -x to the 2011 times 3 to the first power, then plus a bunch of stuff in the middle, and then toward the end here we're going to get plus 2012 times -x to the first power times 3 to the 2011 plus 3 to the 2012. And there we go. Here we have our x term in all of this. And this is going to be the only x term here, not just in this polynomial, but in this entire polynomial. And we see that this thing is equal to, it's big either way, and it's not a fun number to calculate, even on a calculator. But overall, it's negative. So this coefficient right here is negative 2012 times 3 to the 2011. And that's a big number. It's like 6.22 times 10 to the, like 962nd power. And it's big, it's massive, and I'll leave that for you to try to figure out how to calculate, but if I were your teacher, I would be satisfied with this right here. It's a nice compact form, but it's very clearly, this answer is very clearly not simply equal to 1.